Hello, we have learned about the data pre-processing technique. First part was data cleaning, which we have learned in the earlier video. In this video, we will be learning the rest of the three steps. So the second step in data pre-processing is data integration. Data mining often requires data integration, and data integration means the merging of data from multiple data stores. Careful integration can help reduce and avoid redundancies and inconsistencies in the resulting dataset. When matching attributes from one database to another during integration, special attention must be paid to the structure of the data to ensure that any attribute functional dependencies and referential constraints in the source system match those in the target system. Redundancy is another important issue in data integration. An attribute may be redundant if it can be derived from another attribute or set of attributes. Inconsistencies in attribute or dimension naming can also cause redundancies in the resulting data set. Some redundancies can be detected by correlation analysis. Given two attributes, such analysis can measure how strongly one attribute implies the other based on the available data. For nominal data, we use chi-square test. For numeric attributes, we can use correlation coefficient and covariance, both of which assess how one attribute's value vary from those of another. Tuple duplication is also used. In addition to detecting redundancies between attributes, duplication should also be detected at the tuple level, where there are two or more identical tuples for a given unique data entry cases. The next is data reduction. In data reduction, we obtain a reduced representation of the data set that is much smaller in volume, yet it produces the same analytical results. It closely maintains the integrity of the original data. Data reduction strategies include dimensionality reduction, numericity reduction, and data compression. Dimensionality reduction is the process of reducing the number of random variables or attributes under consideration. In dimensionality reduction, data encoding schemes are applied so as to obtain a reduced or compressed representation of the original data. Dimensionality reduction methods include principal component analysis, which transforms or projects the original data onto a smaller space. Attribute subset selection is a method of dimensionality reduction in which irrelevant, weakly relevant, or redundant attributes or dimensions are detected and removed. Next is numericity reduction. Numericity reduction reduces the number of tuples while preserving the important characteristics of the data. In numericity reduction, the data are replaced by alternative small representations using parametric models. In data compression, transformations are applied so as to obtain a reduced or compressed representation of the original data. If the original data can be reconstructed from the compressed data without any information loss, the data reduction is called lossless. We have several data reduction methods such as PCA, principal component analysis, then attribute subset selection, regression methods, clustering, sampling, data cube aggregation. The next method is called as data transformation. In data transformation, the data are transformed or consolidated into forms appropriate for mining. Strategies for data transformation include the following. First is smoothing, which works to remove noise from the data. Techniques include binning, regression, and clustering, which is this, these methods are also used for data cleaning. The next method for data transformation is attribute construction, or we can say feature construction also, where new attributes are constructed and added from the given set of attributes to help the mining process. The next method is aggregation, where summary or aggregation operations are applied to the data. For example, the daily sales data may be aggregated so as to compute monthly and annual total sales amount. This step is typically used in constructing a data cube for data analysis at multiple abstraction levels. The other methods for data transformation are normalization, discretization, data encoding, and concept hierarchy generation. Now, in normalization, the attribute data are scaled so as to fall within smaller range, such as 1.0 minus 1.0 to 1.0 or 0.0 to 1.0. Next is discretization, which transforms continuous numbers into discrete categories. Raw values of a numeric attribute or conceptual labels, they can be replaced by interval labels. Next is data encoding, which changes the format, structure, and representation of categorical labels into numerical formats such as integers or vectors, so mathematical models can read them. Another method for data transformation is concept hierarchy generation. This method is used for nominal data, where attributes such as street can be generalized to a higher concept like city or country. Here we see some examples of data normalization or transformation. So in data transformation, we have certain attributes, and when we transform it with the reduced, we have earlier we had 126 attributes and now we have 115 attributes. Earlier we had 2000 transactions and now we have 1456 transactions. So in data reduction, we have reduced the number of rows, or we can also reduce the number of columns. Here, this is a diagram of cluster analysis which helps us in identifying outliers. So all these points which lie outside the cluster, they are termed as outliers. Thanks for watching the video.